Beneath your feet lies the greatest mystery on Earth. A journey of 4,000 miles through crushing pressure, searing heat, and alien landscapes that no human has ever witnessed. This is the story of what lies at the center of our planet. The latest supercomputer models, seismic data, and cutting-edge science have been combined to create this, a virtual journey to the center of the Earth. What we'll discover will change everything you think you know about the world beneath us. Right now, as you watch this, you're traveling through space at 67,000 miles per hour, spinning on a ball of rock and metal hurtling around the sun. But the real journey isn't happening up there in space. It's happening right here 4,000 miles down in the most extreme environment in our solar system. This is the Kola Super Deep Borehole in Russia. For 24 years, Soviet scientists drilled deeper into the Earth than any human had ever gone before. They penetrated 7.5 miles into the planet's crust. At that depth, they expected to find rock at 212 degrees Fahrenheit. Instead, they found hell. The temperature was 356 degrees Fahrenheit, hot enough to melt lead. The rock behaved like plastic. Their drilling equipment failed, and they discovered something that shouldn't exist: microscopic life, living in conditions that would instantly kill any surface creature. Dr. Sarah Chun is a geophysicist at Stanford University who has studied the deepest drilling projects on Earth. What we found in those deep boreholes challenged everything we thought we knew about the limits of life. We're talking about organisms living under pressures 250 times greater than sea level, in temperatures that would cook you alive. But even this incredible feat, drilling 7.5 miles in a solid rock, barely scratched the surface of our planet. If Earth were a peach, the deepest human-made hole wouldn't even penetrate the skin. To reach the center of the Earth, we need to journey another 3,992.5 miles down. That's like traveling from New York to London, except straight down through increasingly impossible conditions. Our virtual journey begins here at the surface, where familiar life exists. But as we descend, we enter alien worlds that exist nowhere else in the known universe. 10 miles down, we've passed the deepest ocean trenches and the highest mountains. The pressure here is 300 times greater than at sea level. The temperature has risen to 400 degrees Fahrenheit. Any surface life would be instantly crushed and cooked. But we've only just begun our journey. We're still in the Earth's crust, the thinnest layer of our planet. If Earth were an egg, we haven't even broken through the shell yet. 25 miles down, the rock around us is no longer solid. Under extreme heat and pressure, it behaves like thick honey, flowing and reshaping over geological time. Welcome to the asthenosphere. This is where tectonic plates float and slide, causing earthquakes and building mountains. The temperature here reaches 2,500 degrees Fahrenheit, hot enough to melt copper. 50 miles down, we've entered the mantle, a layer that contains more than 80 of Earth's entire volume. This isn't the solid rock most people imagine. It's a sea of semi-molten stone that flows in massive currents, like an ocean of liquid metal. Dr. Michael Torres leads a research team at MIT studying mantle dynamics. The mantle is alive. It's constantly churning, with massive plumes of hot rock rising toward the surface and cool rocks sinking back down. These convection currents have been flowing for billions of years, reshaping our planet's surface. 200 miles down, the pressure is now 70,000 times greater than at sea level. The temperature has climbed to 3,000 degrees Fahrenheit. At this depth, even diamond would melt. But here's what's truly incredible. Scientists believe there may be more water trapped in the mantle than in all of Earth's oceans combined. Not liquid water as we know it, but water molecules locked inside crystal structures under unimaginable pressure. This discovery came from a tiny diamond that reached the surface through volcanic activity. Inside that diamond, researchers found a mineral called ringwoodite, and trapped within it, water from 400 miles below our feet. It was like finding a message in a bottle from the deep earth, says Dr. Chun. This single crystal told us that there's an entire hidden ocean beneath our feet, one that's been there since the planet formed 4.6 billion years ago. For 100 miles down, we've entered one of the strangest regions of our planet, the transition zone. Here, the pressure becomes so extreme that the very atoms in rock crystals collapse and reorganize. The mineral olivine, common in the upper mantle, transforms into a denser structure called spinel. Then, under even greater pressure, it becomes an even denser form called silicate perovskite. This isn't just academic curiosity. These phase transitions create barriers that affect how heat and material move through the planet. Some scientists believe this zone acts like a filter, trapping dense materials and preventing them from rising to the surface. 500 miles down, the temperature reaches 3,500 degrees Fahrenheit. The pressure is now 200,000 times greater than its sea level. At this depth, lead would be compressed to nearly twice its normal density. 700 miles down, we've entered the lower mantle, a vast region that extends for nearly 1,400 miles toward the Earth's center. This is where the real giants of geology live. Supercomputer models reveal massive structures here. Plumes of hot rock hundreds of miles wide that rise from the core mantle boundary like enormous underwater mushrooms made of molten stone. These mantle plumes are responsible for some of the most dramatic features on Earth's surface. The Hawaiian island chain exists because it's sitting above one of these plumes. As the Pacific plate moves northwest, the plume burns through it like a cosmic blowtorch, creating a chain of volcanoes across 3,600 miles of ocean. Dr. Lisa Park, a geodynamicist at Caltech, studies these deep Earth processes. These plumes are like conveyor belts of heat. They start at the bottom of the mantle, nearly 1,800 miles down, and take millions of years to rise to the surface. When they finally break through, they create some of the most powerful volcanic eruptions in Earth's history. 1,000 miles down, we're now deeper than the distance from New York to Miami, but we're traveling straight down through rock heated to 4,000 degrees Fahrenheit. At this temperature, most metals would vaporize, but the pressure here, 350,000 times greater than its sea level, keeps everything in a strange, super-compressed state. Water at this depth would be 40 denser than ice. 1,600 miles down, we're approaching one of the most mysterious regions of our planet, the D double prime layer, or D, as scientists call it. This thin zone, just 60 miles thick, sits at the very bottom of the mantle, directly above the outer core. It's a graveyard of geological history, the final resting place of ancient ocean floors that have been subducted and dragged down by tectonic plate movements over billions of years. Dr. Vedran Lekic from the University of Maryland uses seismic waves to map these deep Earth structures. The D layer is like an archaeological site buried under 1,600 miles of rock. We can see the remains of ancient continents, ocean floors, and even meteorite impacts that struck Earth billions of years ago. It's all been recycled and preserved in this strange, compressed form. The temperature here reaches 4,500 degrees Fahrenheit. The pressure is 1.3 million times greater than at Earth's surface. Under these conditions, the behavior of matter becomes exotic. Some scientists believe this layer contains post-perovskite, a mineral phase that can only exist under the most extreme conditions found anywhere in the solar system. 1,800 miles down, we've reached a boundary more dramatic than the surface of any planet. Here, solid rock gives way to liquid metal. Welcome to the outer core. This is an ocean 1,400 miles deep. But instead of water, it's made of molten iron and nickel heated to 5,000 degrees Fahrenheit, nearly as hot as the surface of the sun. But this isn't a calm ocean. Powerful currents of liquid metal flow at speeds of up to 10 miles per year, faster than your fingernails grow. These currents generate something that makes life on Earth possible, our planet's magnetic field. Dr. Bruce Buffett, a geophysicist at UC Berkeley, studies Earth's magnetic field. The outer core is essentially a massive electrical generator. As the liquid iron moves, it creates electric currents, and those currents generate magnetic fields. It's the same principle that powers the generator in your car, except this one is 1,400 miles thick and protects all life on Earth. 2,000 miles down, the pressure is now 1.5 million times greater than at sea level. If you could somehow survive the heat, this pressure would compress your body to the size of a marble. The magnetic field generated here extends far into space, creating an invisible shield that deflects deadly solar radiation. Without it, Earth's atmosphere would be stripped away by solar wind, leaving our planet as barren as Mars. 2,200 miles down, we're about to cross one of the most important boundaries in Earth science, the Lehmann discontinuity, named after Inge Lehmann, the Danish seismologist who discovered it in 1936. Lehmann was studying earthquake data when she noticed something strange. Seismic waves were arriving at her instruments faster than they should have, suggesting they had traveled through something denser than liquid metal. Her conclusion was revolutionary. There was something solid at the center of the liquid outer core. She had discovered the inner core using nothing but earthquake waves and mathematical calculations. Inge Lehmann's discovery was one of the greatest achievements in earth science, says Dr. Leckich. Using just the tools available in the 1930s, she mapped the center of the Earth more accurately than we could map the surface of Venus at the time. 2,900 miles down, we crossed the boundary between liquid and solid metal. The pressure here is so extreme, 3.6 million times greater than at sea level, that iron and nickel are compressed into a crystalline structure unlike anything found anywhere else in the universe. Welcome to the inner core. This sphere of solid metal, 800 miles in diameter, is nearly as large as the moon. The temperature is 6,000 degrees Fahrenheit, the same temperature as the surface of the sun. But here's the paradox. Despite being hotter than the outer core, the inner core is solid. The pressure is so immense that it forces the iron into a solid crystalline state. Dr. John Vidal at USC uses earthquake waves to study the inner core structure. The inner core isn't just a simple ball of iron. It has structure, it has layers, and it's constantly changing. We've discovered that it rotates slightly faster than the rest of the planet, about 1/5 of a second per year faster. This means that relative to the surface, the inner core completes an extra rotation about every 1,200 years. It's like a planet within a planet, spinning at its own rate. 3,200 miles down. We're now deeper than the distance from Los Angeles to New York. But we're traveling through a solid ball of iron heated to stellar temperatures. Recent discoveries have revealed that the inner core isn't uniform. It has an eastern and western hemisphere with different properties. The eastern hemisphere, under Asia and the Pacific, seems to have iron crystals aligned in one direction. The western hemisphere, under the Americas and Atlantic, has crystals aligned differently. It's like the inner core has a split personality, explains Dr. Vidal. We think this might be evidence of how the inner core formed. Perhaps it grew asymmetrically over billions of years. 3,500 miles down, the pressure reaches 3.7 million times sea level pressure. At this depth, the atomic structure of iron itself begins to change. The electrons are squeezed so tightly that they behave in ways predicted by quantum physics, but never observed in any laboratory. 3,800 miles down, we're approaching the most recent discovery in deep Earth science, the innermost inner core. In 2023, scientists analyzing earthquake data discovered evidence of yet another layer at the very center of our planet. This innermost core, about 240 miles in diameter, appears to have iron crystals oriented in a completely different direction from the rest of the inner core. Dr. Tan Sun Pham from the Australian National University led the research team. This discovery suggests that the inner core went through a major change in its formation history. There was a significant global event that changed how the inner core was growing. The implications are staggering. This innermost core might represent a completely different phase of Earth's evolution, perhaps evidence of a massive asteroid impact, or a fundamental change in how our planet's magnetic field operated billions of years ago. 3,950 miles down. We're in the final 50 miles of our journey, traveling through matter compressed to densities found nowhere else in the known universe. The iron here is nearly twice as dense as iron at Earth's surface. The temperature fluctuates between 5,700 and 6,300 degrees Fahrenheit. These temperature variations drive convection currents in the outer core that have been flowing for over 4 billion years. 3,970 miles down. We're now closer to the center of the Earth than most commercial satellites are to the surface. The pressure is 3.64 million times greater than at sea level. A cubic inch of matter here weighs 43 pounds, 3,963 miles from the surface. We have reached the geometric center of planet Earth. Here, at the very heart of our world, gravity pulls equally in all directions, creating a zone of weightlessness surrounded by the most extreme pressures in the solar system. The temperature is 6,000 degrees Fahrenheit, as hot as the sun's surface. The pressure is 3.64 million atmospheres. A drop of water here will be compressed to the density of lead. But perhaps most remarkably, this point has been in motion for the entire 4.6 billion year history of our planet. As the inner core slowly rotates, the very center of the Earth traces out a tiny circle just a few feet across, once every 1,200 years. From the center point, we can see the entire engine of our planet at work. Heat flows outward from the inner core, driving circulation in the liquid outer core. This generates Earth's magnetic field, which protects all life on the surface. The heat continues outward, creating massive convection currents in the mantle that move continents, build mountains, and cause earthquakes. These same currents bring nutrients from the deep Earth to the surface, making complex life possible. Dr. Barbara Manouch from UC Berkeley studies how the deep Earth connects to surface processes. Everything we see on Earth's surface, from the air we breathe to the ground we walk on, ultimately comes from processes that begin at the center of the planet. The deep Earth isn't separate from our world, it is our world. The journey to Earth's center reveals more than just extreme physics. It shows us that our planet is fundamentally alive, not in the biological sense, but as a dynamic, evolving system where every layer interacts with every other. The carbon in your body was forged in the deep mantle billions of years ago. The oxygen you breathe was liberated from rocks by processes powered by heat from the inner core. The magnetic field that protects you from deadly cosmic radiation is generated by currents flowing 2,000 miles beneath your feet. But even after this incredible journey, mysteries remain. Scientists estimate we know less about the deep interior of our own planet than we do about the surface of Mars. How exactly does the magnetic field reverse itself, as it has done hundreds of times in Earth's history? What causes the mysterious seismic anomalies detected in the deepest parts of the mantle? Could there be forms of matter in the inner core that don't exist anywhere else in the universe? Dr. Vidal explains the challenges. We can send spacecraft to Jupiter, but we'll never send anything to Earth's core. The pressure would crush any material we can imagine, and the heat would vaporize it instantly. So we have to be detectives, using earthquake waves and computer models to piece together this incredible puzzle. New technologies are opening new windows into the deep Earth. Supercomputers can now model the behavior of matter under the extreme conditions found in the core. Networks of sensitive seismometers are mapping the deep Earth structure with unprecedented resolution. Researchers are even using particle accelerators to recreate the pressures and temperatures found thousands of miles below our feet, revealing how matter behaves in these alien conditions. We're entering a golden age of deep Earth science, says Dr. Chun. In the next decade, we'll learn more about the interior of our planet than in the entire previous century. As we begin our return journey from the center of the Earth, we carry with us a new understanding of our planet. Earth isn't just a rock floating in space. It's a sophisticated machine powered by nuclear decay and gravitational energy that has been running continuously for 4.6 billion years. Rising through the inner core, we see how crystalline structures form under unimaginable pressure. Entering the liquid outer core, we witness the birth of the magnetic field that makes life possible. Ascending through the mantle, we observe the massive convection currents that reshape continents over geological time. These aren't just abstract scientific concepts. They're the fundamental processes that created the world we inhabit. Breaking through Earth's crust, we return to the familiar surface world. But now we see it differently. Every mountain, every ocean, every grain of sand tells the story of processes that began thousands of miles below. The Hawaiian Islands exist because a plume of hot rock rose from the core mantle boundary. The Himalayas grew because convection currents in a mantle pushed continents together with irresistible force. Even the atmosphere we breathe was exhaled by volcanoes powered by heat from the planet's interior. The water in our oceans may have spent millions of years locked in crystal structures hundreds of miles underground before returning to the surface. The journey to Earth's center reveals the ultimate truth about our planet. It's not just the place where life exists, it's a machine that makes life possible. Every breath you take, every step you make, every heartbeat is connected to processes happening thousands of miles below your feet. You're not just living on Earth. You're part of Earth, a temporary arrangement of atoms that were forged in the deep interior and will one day return there. The magnetic field protects you from space radiation. Heat from the core drives the water cycle that brings fresh water to the continents. Plate tectonics, powered by mantle convection, regulates Earth's temperature by controlling how much carbon dioxide remains in the atmosphere. Earth isn't just a habitable planet, explains Dr. Romanowicz. It's a planet that actively maintains its own habitability. The deep Earth processes don't just allow life, they sustain it. Our journey to the center of the Earth may be complete, but the real journey is just beginning. Every earthquake provides new data about the deep interior. Every volcanic eruption brings samples from hundreds of miles down. Every magnetic field measurement reveals more about the dynamo operating in the outer core. Scientists estimate it will take another century of research to fully understand the complex machinery operating beneath our feet. New discoveries await in the deepest realms of our planet. Perhaps we'll discover new forms of matter that exist only under the extreme conditions of the deep Earth. Maybe we'll learn that the inner core contains materials from the original solar nebula that formed the planets. We might even find evidence that the deep Earth processes are more complex and interconnected than we ever imagined. But one thing is certain. The 4,000-mile journey to the center of the Earth is really a journey to understanding our place in the universe. We are not separate from our planet. We are Earth expressing itself as consciousness, life, and curiosity. The greatest mysteries aren't in distant galaxies or alien worlds. They're right here, thousands of miles beneath our feet, in the fiery heart of the only planet we can call home. The journey to the center of the Earth reveals that our planet is not just a place where amazing things happen. It is the amazing thing that makes everything else possible. For 1,000 miles down, in the center of everything, burns the engine that powers the miracle we call Earth. The journey ends where it began, with wonder at the incredible machine that is our planet, and recognition that every moment of existence is made possible by forces operating in the deepest realms of the world beneath our feet.